Hello and welcome to another episode of the Fully Charged Show. Now, what I've got beside me here, this big thing here, that is a 16-litre diesel engine. And that is the sort of engine that you have in a big truck. We've been using this technology to move the goods around the world on the ground for the last, I don't know, 120 years. They've gradually got bigger and bigger and more powerful. The trucks have got enormous. They're absolutely massive now. This is incredibly reliable, solid, good old-fashioned proper engineering. It works, it lasts for hundreds of thousands of miles. It costs an enormous amount to maintain. It costs a vast amount to fuel. It burns through hundreds of thousands of litres of incredibly toxic imported fossil fuel. That's the downside. The upside is, you know, we've been doing them for years and we all understand how diesel engines work. But what if you could take this out of one of those big trucks and replace it with an electric motor and a big load of batteries that you can swap in 1 minute? It's quicker to charge up an electric truck than it is to fill up a diesel tank. It's faster. That is really exciting. We've come here to Janus Trucks in New South Wales, Australia, to see how they do it.
Like the Fully Charged Show? Then you will love our 6 live shows being held around the world in 2023, starting with Sydney, Australia on March the 11th and 12th.
When we started the Janus business model, what we wanted to do was remove the imposts to heavy vehicle electrification.
Yeah.
So we've developed a system that enables the conversion of every new and used truck in the world.
Right.
And we remove the impost of battery charge time.
We're going to make this simple. It's got to work effectively. It's got to work across all models. We don't want to be a truck manufacturer. We just want to re-energise them.
Yeah.
And that's why we've done 5 different models and makes, and our system works across all of them.
When you have a look at the conversion modules here and in the truck, you'll see that they're the same envelope as a 13-litre diesel engine.
Right.
Essentially, that means that the Janus conversion module can fit in any Class 8 or above truck in the world.
We'd love the OEMs to say, hey, we just want to use your exchangeable battery technology. Build your electric truck, put the exchangeable technology on it. That is better for the grid, better for the trucking operator. Takes away that charging and ranging anxiety of, oh, I've got to be somewhere, but it's going to take me 6 hours to charge that vehicle to get the full charge. And that's, this fallacy of fast charging. If you're going to put fast charging networks in, you've got to have storage, and that's what our charge stations also offer, is a storage capacity, so that it can be utilised when the vehicles come in rather than waiting for that vehicle to turn up. You ready to go?
Yeah.
Righto. So it's just a simple foot on the brake, put it into D for drive.
Right.
It selects gear, and we're in gear 3, and away we go. So just put the accelerator in. It's no clutch, so it's all automatic.
Yeah.
You've still got to have gears because of the weight of the vehicle. So this is one of the heaviest road-going rated electric trucks in the world. So this is 97-tonne rated. So this is a double capacity of what the Tesla Semi is, and what the Volvos are rated to 44 tonne. We're rated to 97 tonne.
97
So we can tow 2 trailers. So similar to what we've got in front of us there, we can put 2 trailers on.
So this is an equivalent 16-speed automatically shifting manual gearbox.
Right.
So the key difference between trucks and cars is a truck needs a lot more torque at the wheels to get off the mark, particularly when you're on steep inclines, purely because of the mass of the vehicle. So all Janus vehicles are 90-tonne plus rated trucks.
Right.
So you compare that to your average, for example, Tesla, you're at about 2 tonnes. So it's absolutely necessary to run a gearbox with a large vehicle.
Right.
So right here we have a 720 horsepower or 540 kilowatt drive, which is equivalent to the 16-litre Volvo engine that came out of the truck behind us.
Right.
So this is exactly the same power and torque characteristics at 2,000 RPM as the 16-litre Volvo engine that came out of the truck.
Right.
And to get the torque required to move a truck at such high gross vehicle masses to the rear wheels, we run through a conventional truck gearbox.
Right.
So even though there is a gearbox, it's fully automatic. So it operates in the same manner as an automatic gearbox on a diesel truck does, with the exception that you actually don't need a clutch. Because with the electric motor, you've got infinite control over the RPM of the motor. We can simply shift to neutral, speed match, and shift to the next gear seamlessly.
Right. But then the other thing is, I just want to really point this out, is that I've been in lots of kind of, in big inverted commas, experimental vehicles where people have, converted things, but this is in use, commercially in use.
Yes.
So there's a company using this
Correct.
truck to deliver sand, and they get paid to do it.
Correct.
So it's just
it's
just being used all the time.
It's the first truck in commercial operations of a Class 8 in Australia.
Right.
In commercial operations as we speak today.
And I mean, roughly what range can it do then when it's on a full?
Look,
I suppose it depends on so many things.
Yeah, it depends on the topography where it's operating,
What load is?
what the load is. Is it in a space where they can get lots of regenerative braking?
Right.
All of those sorts of things. So. It all basically comes back to what it's towing. So somewhere between 400 to 600 kilometres.
Right.
Depends on the regenerative braking. Some applications only around 300 kilometres because of
It's
load
such a
factor.
big weight, and you've got a hill.
Yeah. The other side, like the two big factors that affect your range is your rolling resistance, so how many axles you're towing on the ground.
Right.
And then how big is the brick you're trying to push through the air.
Yeah.
Like this truck has not got a lot of wind efficiency in it. It's very, it's got shiny things all over it.
Yeah.
It's got a big wing foil.
Yeah.
It doesn't need to be doing that. So it averages sort of around that 1.5 to 1.7 kilowatt hours per kilometre.
Right.
Yeah.
That's a good way of judging it. So I mean, for people who don't know, I mean, an efficient electric car will get between 4.5 and 5 miles, so about 7 or 8 kilometres per kilowatt hour.
Sure.
This uses 1.5
kilowatt hours per kilometre.
Right.
Yep.
So what I'm leaning on is a battery pack, and what used to be here were 2 enormous diesel fuel tanks, but this has replaced them. This is 620 kilowatt hours of electricity. That is about 8 Tesla Model 3s in just this pack. And then it weighs 2.08 tons. So there's 2 of these. There's another battery pack the same size on the other side of the truck.
So essentially, when you take the diesel engine, fuel tanks, fuel load, exhaust systems, intercooler, etc., you remove all that out of the truck. You're moving about 3.5 tons of weight.
Right.
And then when you put the Janus system back on, you're actually putting about 4 tons back in.
Right.
So you're about half a ton to a ton heavier than your conventional diesel at the moment.
The cost of running this, driving it a kilometre, has got to be cheaper than a diesel one. I mean, am I way out of line there?
No, you're right. So you're looking, if you're talking apples for apples with energy, you're looking at about 60 cents a kilometre with a electric vehicle, as opposed to $1 a kilometre with a diesel vehicle at the moment with current fuel prices.
Right. And that is if you charge it from the Australian grid, of paying grid prices per kilowatt hour.
Correct.
Right.
Correct.
So even that is cheaper. But if you can make your own fuel.
Yeah, you hook it to solar, hook it to wind, get into renewables, get behind the meter, get off grid.
Yeah.
Look at warehouses and put the solar on the top of the warehouses.
Yeah.
You're bringing that fuel cost down to about 6 cents a kilowatt hour as opposed to about 25 to 26 in the Australian grid delivered at the moment.
Yeah.
So it has significant economic benefits for the fleet operator, but not only for the fleet operator, but we then start to get energy sovereignty and energy security back in our country.
Yeah.
Because we've got an abundance of renewable energy in this country. We import 95% of all of our fuel for this country.
Wow, really? That much? I didn't realise it was that high.
95%. There's only about 14 days of diesel in this country at any one time.
Wow.
Because there's physically not the tank storage for it, and we only produce about 5% of it ourselves. The rest of it's on ships. So we're just coming back into the charge station here, so you can see there's a battery. There's a battery in the charge station ready to go for us.
Wow.
We'll just pull up and we can do we'll show you a battery exchange. With exchangeable batteries, you
can charge them when it's good.
Well, you charge when renewables are in production.
Yeah.
You charge out of peak, so you're not putting an extra load on the grid. You're actually utilising the grid infrastructure when it's not in full use.
Yeah.
So in Australia we have a peak between 7 a.m. and 9 a.m. in the morning, and then another peak at around 4 p.m. in the afternoon to about 9 p.m. at night. The rest of the time that infrastructure is completely underutilised.
Right.
So we've got to be smart about how we do this. Instead of having to put billions of dollars into electrical grids, how do we use that infrastructure more efficiently?
Yeah.
Same principle with the truck. This truck's 10 years old.
Right.
And it's fully electric.
Right.
It's a 2012, sorry, it's 11 years old this year.
Right.
It's a 2012.
Right.
It had done 1.3 million kilometres when we got it.
Right.
You wouldn't think it was a 1.3 million kilometre truck. So it's a second life. It's about utilising infrastructure and assets and repurposing and keep that circular economy going round and round. There's only a 5% manufacturing capacity in vehicles in OEMs around the world. So they can only ever manufacture 5% of the total fleet.
Right, I see what you mean.
So if we're going to
Okay.
try and hit targets of 2030 and 2050 zero emissions,
We've got to use what we've got.
you've got to reuse it, and you've also got the carbon debt for the manufacturing of this original vehicle.
Yeah.
And typically, the average age of every prime mover around the world is between 13 to 15 years of age.
Right.
So when you look at that and you look at it and go, well, 13 to 15 years of age, they've typically had 2 to 3 engine rebuilds in that period of time.
Right.
Because every 800,000 to 1 million kilometres, or 600,000 miles, 700,000 miles, they need an engine rebuild.
Right.
So rather than rebuild the engine,
Just
let's take it out. And let's put an electric one in.
I mean, essentially, electric motors are protected in their software, so it's almost impossible to overstress these motors. They're temperature protected, they're power protected, and so forth. So the motors realistically have a multi-decade life. Right. So there's no issue with maintenance. The motor's no usable serviceable parts.
Right.
So we're expecting multi-decade lives out of the motor and multi-million kilometre lives.
Right.
The
Wow.
gearboxes, because there's no vibration and heat coming back from a diesel engine, we expect that the life of the gearbox will more than double.
Right.
So generally on a gearbox, you re-race a gearbox at about 1 million kilometres, maybe 1.2, 1.5 million kilometres. But because there's no shock load coming back through from the clutch, there's no heat from the engine, there's no high frequency vibration from the pistons, essentially reciprocating. We expect that will double the life of a gearbox.
Right.
What you can see in the screen, the only main modification is the screen that goes in the vehicle. So that gives us motor speed, what gear we're in, and the percentage of charge of the battery. So it's got 24% in it.
Right.
But what we're then able to do then is jump, and we can see our regenerative torque, and we use the existing engine brake switch in the truck as the regenerative setting. So we've got 3 settings. So you've got a light, a medium, and a high duty. So we've got 2,800 Newton meters of regenerative torque there, set as the highest setting. So it will stop you on a 10-15% grade. It'll pull the truck up to a stop.
Wow.
So with trucks, it's not only nice to regeneratively brake to regain power, it's actually necessary, because you have to assist the truck in braking, particularly on long downhill declines. So this motor, for example, will return 540 kilowatts of energy to the battery pack.
The significant saving just in operating an electric vehicle in maintenance over a diesel vehicle is huge. A typical vehicle doing metropolitan deliveries around 14 to 16 cents a kilometre for maintenance for a diesel.
Just for the maintenance.
Just
That's
for the
thing
maintenance
that we don't think about.
And the downtime.
Yeah.
So that's the other part. When you're doing a major engine oil service, it's 6
not
hours off
working.
the road.
Yeah.
There's no engine oils to change on these. So we're looking at maintenance at below 4 cents a kilometre for an electric vehicle. And you felt the regenerative braking when we went for a drive.
Phenomenal.
You don't touch the brakes.
No.
So you take that into equation. It's just got so many benefits for the transport industry, and that flows on then to us as a community as well too, because think about the noise and the pollution that we save in concentrated in residential areas. Greater delivery scope of windows as well too, because less noise, 24-hour delivery cycles into suburban areas. It just makes a significant change to the whole logistics and community.
And I mean, have you got a kind of rough budget of what it costs to convert one?
To do a conversion, you're looking at about $150,000 to $175,000 Australian at the moment, depending on the type of vehicle. That doesn't include your batteries. The batteries is basically energy as a service, because the dearest thing on an electric vehicle is the batteries.
So you don't sell the batteries to the truck company.
The truck can own their batteries if they want, but I say to them, why do you want to own an asset where there's millions of dollars, well, actually probably closer to billions of dollars being spent on battery cell technology, and limit yourself to that technology today? The beauty of our system is as a new cell chemistry comes available, we just put it in the box.
One of the things we'll be doing over the next 12 to 24 months is installing robotic charge and change stations as well. And that will reduce the change time, the battery swap time, to sub 1 minute.
Wow.
So the truck will drive into essentially a building. Driver will exit the vehicle into what we call a safe area, just for good governance. And robots will literally pull the battery, swap it with a full battery, and then rack the depleted battery. And the driver will then be allowed to re-enter the vehicle.
Wow.
but that whole process will take less than a minute.
Wow.
Now, the great thing about our batteries, people say, well, what are you going to do with them when they're finished in trucks? Well, we just take that out, and it's because it's a fixed capacity. We'll be at 80% capacity in that battery. We use it as a grid storage battery. We use it as static storage. It can be easily reutilised in other areas where we need to have static storage, grid support, FCAS, backup batteries. You think about replacing diesel backup power underneath hospitals and underneath high-rise buildings. For fire systems, just put our battery in there and just feed it off the grid when it makes sense, when the power makes sense.